Now we can put everything together. Solving a linear inequality is just like solving a linear equation, except that instead of an equal sign, I have an inequality symbol. But working the problem means pretending for the moment that instead of an inequality here, we have an equal sign. What would we do first in this case? Because I see parentheses here, I'm going to distribute. My left-hand side becomes 3x minus 3 times 4. My right-hand side is just negative 2. In an equation, I'd bring down the equal sign. We need to remember that this isn't an equation, but an inequality. So instead of bringing down the equal sign, I need to bring down the inequality symbol. Before I do, let me ask myself, did I multiply or divide both sides by a negative number? No, in fact, I didn't multiply by anything. All I did was distribution. I didn't do anything to both sides. I simply changed the way the left-hand side looked. So I can just copy down my inequality symbol, as though it were an equal sign. In the next step, I should add 12 to both sides of my equation, if it's an equation that I'm solving. When I do this, I get 3x plus 0 on the left-hand side, or just 3x, and on the right-hand side, negative 2 plus 12, which is 10. Solving an equation, I would bring down the equal sign. But remember, this isn't an equation, it's an inequality. So I need to bring down the appropriate inequality symbol. Did I multiply or divide both sides of this inequality by a negative number? No, I just added 12 to both sides. So that inequality symbol does not change. In my next step, I'm going to divide both sides by 3 to get the x completely by itself. This gives me x on the left-hand side and 10/3 on the right-hand side. In an equation, I'd be able to say that my solution is x equals 10/3. Bring down the equal sign. Once again, this is an inequality, not an equation. So I need to bring down the inequality symbol. I can't just copy it down unless I ask myself first, did I multiply or divide both sides of the inequality by a negative number? No, I divided both sides, but I divided by a positive number. So the inequality doesn't change direction. Here's my final answer. X is greater than or equal to 10/3. I've solved the inequality, but now I need to graph it. The instructions were to solve and graph. First, I'll look for my cutoff point. The cutoff point is the number that would have been the solution to the equation, x equals 10/3. X equals 10/3 is a dot on the number line at the point where the value is 10/3. I can think of 10/3 as 10 divided by 3 with a remainder of 1. 3 1/3. So that would be about here. So I'm going to put an open circle at that point on the number line. I'll determine in a minute whether or not I need to close that circle. All I'm doing right now is noting the position of my cutoff point, 10/3. I wasn't solving an equation, I was solving an inequality. So the remainder of the graph has two parts. First of all, do I close in the circle or not? And which direction does the arrow go? Since x is greater than or equal to 10/3, the values I'm allowed to use, or the values that will satisfy the inequality, are all the numbers that are greater than 10/3, or bigger than 10/3, or in fact, equal to 10/3. So the direction of the arrow goes to the right to indicate the numbers are bigger than 10/3, and the circle gets colored in to indicate that x can be equal to 10/3. This is the solution to the inequality. Solve and graph This is the solve part. This is the graph of the solution to this inequality. Here's our next example. If this were an equation instead of an inequality, I would do distribution, 2 times 1 minus 2 times 3x plus 4 equals 4x minus 4. It's not an equation, it's an inequality. But I haven't multiplied or divided by a negative number, so my inequality symbol doesn't change. The next step would be to combine like terms on both sides. 2 plus 4 is 6, minus 6x equals 4x minus 4. Did I multiply or divide by a negative number in that last step? No, just combine like terms on the left-hand side. Next, I might subtract 4x from both sides. This would give me 0 minus 4 on the right and 6 minus 6x minus 4x on the left. In an equation, I would just bring down the equal sign. In an inequality, I would just bring down the inequality symbol as long as I've not multiplied or divided both sides of the equation by a negative number. And I haven't, I've subtracted. So this is my correct inequality symbol. Now I'll subtract 6 from both sides. So the variable term is the only thing left on the left-hand side. In an equation, these would be equal. Let's move our work up to here so we can continue. I currently have negative 10x is equal to negative 10. And now I can continue. My next step would be to divide both sides of the equation by negative 10 to get rid of this negative 10. This leaves me with x on one side and positive 1 on the other. In an equation, I would say that x was equal to 1. Since I wasn't doing an equation but an inequality, I have to ask myself, can I just copy this symbol down? Or did I multiply or divide both sides of this step by a negative number? And I did. I divided both sides of this inequality by the number negative 10. So rather than just copying this down, I need to flip it over so that it's pointing in the opposite direction. Here's my solution. X is greater than 1. Let's graph it. Here's my number line. Let me start the graphing process by plotting the point that's my cutoff point. No fractions this time, just 1. Now I'll go back to the actual solution, the inequality. X is greater than 1. The two parts that remain to graphing this include the direction and whether or not to close in the circle. This solution says that x has to be greater than 1, so the direction of the arrow is to the right because that's where the numbers on the number line are greater than the number 1. Should I close in the circle? Not this time, because this says that x has to be greater than 1, not greater than or equal to 1. It can't actually equal 1. It's like saying I can run up and bump into the number 1, but I can't actually land on it. This is actually the graph of my solution. Most of you won't bother with colors. It'll just look like this. An open circle at 1 and an arrow that goes to the right. This is the graph of the solution to this inequality.